Hi students, welcome back. Today we are going to discuss about the classification of mixtures. We know that all solutions are mixtures, but all mixtures do not exhibit the same nature. Let's study about homogeneous mixtures and about heterogeneous mixtures. In a mixture, the composition of the constituents is the same throughout the mixture. It is known as a homogeneous mixture. All solutions are homogeneous mixtures. Sugar solution, salt solution, air, ornamental gold, etc. are examples for homogeneous mixtures. The components of such mixtures cannot be seen separately with the naked eye. Next is heterogeneous mixtures. If the components in a mixture are not distributed uniformly, it is known as heterogeneous mixture. For example, a mixture of salt and sand, muddy water, a mixture of water and kerosene, etc. are all examples for heterogeneous mixtures. Here the components can be seen separately with the naked eye. In page number 217 of your textbook, there is a picture given. Copper sulfate crystals in the first, milk in the second and chalk powder in the third beaker. Stir them well and keep the beaker undisturbed for some time. You can notice the substance settle down where the beaker which contains chalk powder and water. The first beaker contains the true solution, the second contains a colloid and the third contains a suspension. Let's discuss more about this. In a true solution, the particles cannot be separated by filtration. When an intense beam of light is passed through the solution, the path of light is not visible. In a true solution, the particles cannot settle down. These are the properties of true solution. Next is colloids. The particles cannot be separated by filtration. When an intense beam of light is passed through the colloid, the path of light beam is visible. In a colloid, the particles cannot settle down. Colloid is a form of mixture which is neither a solution nor a suspension. The size of the particles in colloid is too small to be seen by the naked eyes. And about suspension, in a suspension, particles can be separated by filtration. When a beam of light is passed through suspension, we can't see the beam of light because it cannot conduct light. In suspension, the particles settle down. The solution of chalk powder and water contain biggest particle. The size of solute particles present in a solution is so small that it cannot be seen with the naked eye. Since these particles are very minute, they cannot scatter a beam of light. Hence, the path of light beams is not visible. In the case of colloids, the solute, that means colloidal, particle size is comparatively bigger. Hence, they scatter a beam of light, thus making the path of the beam visible. Particles of suspension are big enough to be seen with the naked eye, the light falling. So students, let us consolidate the peculiarities of colloids and compare it with the peculiarities of solution and suspension. The difference in the properties of true solution, a colloid and a suspension is due to the different size of their solute particles. The solute particles in a true solution are very small. The solute particles in a colloid are slightly bigger, whereas the solute particles in a suspension are quite big. It is due to the small size of their solute particle that a true solution and a colloid easily pass through the pores of a filter paper, whereas it is because of the bigger size of the solute particles of a suspension that they cannot pass through the pores of a filter paper and are retained on the filter paper in the form of a residue. Only the solvent of a suspension passes through the filter paper in the form of a residue. Students, here is a picturization when a beam of light passes through solution, colloid and suspension. Students, let's summarize our today's session. Today we discussed about homogeneous mixtures, heterogeneous mixtures, and about true solution, colloids and suspension. That's all for today. See you on the next class. Thank you.